Okay, we are ready to try Fourier analysis on waveform 1. This is the square wave that we looked at, given by Vmax and negative Vmax respectively for the first half cycle and the second half cycle. We should begin by stating any symmetry present. The waveform is odd, which means there is no constant term and there is no cosine term. Those cheats, by the way, were listed at the bottom of the handout from last day. If there's no constant term, we will not use this formula. If there's no cosine term, we will not use this formula. So the Bn formula is the only one we need to use here. The fact that the waveform has half-wave symmetry will also be important towards the end of this problem. We have no even harmonics, so we will only be substituting odd numbers for n, for little n. Okay, let's begin with that Bn formula. The formula itself has a lower limit of 0 and an upper limit of capital T. Our waveform, however, has two distinct pieces, which means we have to split our integral like this. The first integral will go from 0 to t over 2. The second from t over 2 to t. V at t is replaced by Vmax here and negative Vmax here. Okay, to evaluate these integrals, I remove Vmax as common first. You can see that that will be out front in the next step, like this. Each of these can be integrated by noting that the integral of sine is negative cosine, but we have to remember also to divide by the derivative of the angle. The derivative of each angle is 2 pi n over capital T. So that means 1 over that is t over 2 pi n. So here is the t over 2 pi n in front of negative cosine. The angle stays the same. Here again, we use the negative cosine, but the term was already negative, so now we have positive cosine. Notice the angle remains exactly as it was. The only difference is this constant out front. That integral, by the way, that integral, can be found also on the formula sheet. The integral of sine is negative cosine, but with t over 2 pi n preceding. Okay, out front, this will now simplify to Vmax over n pi. Since I had one negative term and one positive term, I've changed their orders here as well. Okay, so there's the simplified new constant, and I wrote this term first. You can see this term is first, and then after the subtraction sign, this term. Okay, you don't have to do that. I just chose to. I liked having my positive term first, then minus this other term. Okay, now we have to substitute upper limit and lower limit. Upper limit and lower limit using subtraction in between. We substitute, of course, for the variable little t. So first we put capital T here. That'll give us an angle of 2 pi n. Then we put capital T over 2 here, and that will give us an angle of n pi. Similarly here, capital T over 2 will go in first, giving us an angle of n pi. Then 0 will be our angle. And that looks like this. Okay, so in a bracket, first I substituted capital T, then capital T over 2. This subtraction sign is here, and then in a bracket, first I substituted capital T over 2 and then 0. Okay, of these things, this item can be evaluated immediately. The cosine of 0 is 1. These are like terms, so I've collected them in the next step. I'm going to have negative 2 cosine n pi in the next step. Okay, so this term is here. These two collected are here. And this term, look, watch your signs though. This term is positive 1 at the end. Okay, now here, regardless of the value of n, the 2 here makes this an even number of pi terms. Okay? So the cosine of 2 pi would be the cosine of 4 pi would be equal to the cosine of 6 pi, which would equal the cosine of 8 pi, and so on. All of those have a value of 1. But in this term, this is when we have to remember there are no even harmonics. So we are substituting odd numbers for n, like 1, 3, 5. What is the cosine of 1 pi? It's negative 1. The cosine of 3 pi would also be negative 1. And of 5 pi, negative 1. Okay, and remember that this document is posted for you showing, this one is cosine here, showing the waveforms. Okay, this is what I'm talking about. That's pi. Cosine of 1 pi is negative 1. 3 pi would be here, also negative 1, and so on. Okay, so this means in this bracket we have positive 1, minus 2 times negative 1 is positive 2, and at the end, positive 1, so 4. And this is the general term Bn. Bn is equal to 4 V max over n pi. So what we can do is work out some of these specific coefficients now. So now that we have this Bn formula, let's work out, let's do 4 terms. So here's the general formula for Bn. I'm going to substitute n is 1, 3, 5, 7, and I get these. Okay, so we put a 1 here, a 3 here, a 5 here, a 7 here. And now, in order to write out the Fourier series expression, we need to remember what the formula looks like. This is the formula in its expanded form, but we don't have any constant term, nor do we have any cosine terms. We only have terms like this, but not even the even ones. So we're going to have our B1 coefficient in front of this, the sine of 2 pi over capital T times little t. Then we're going to have our B3 term in front of this, the sine of 6 pi over capital T times little t. Then we will have a B5 coefficient in front of the sine of 10 pi over capital T times little t. Okay, and lastly, there'll be a B7 term, B7 coefficient in front of the sine of 14 pi over capital T times little t. Okay, you notice if that's a 3, that's going to be a 6. If that's a 1, that's a 2, right? It's double, and that's because you can see what the formula looks like in this summation form. 2 times, right? 2 times. Okay, anyway, let's write it out. Okay, so this is B1, our calculated B1. This is the sign term that corresponds. This is B3 with the sign term that corresponds, plus B5 with the sign term that corresponds, and B7 with the sign term that corresponds. Indicate like this that it is an infinite series. Lastly, what I did was, you can see that each of these coefficients has 4v max over pi common. So I've removed it from each. That would leave you with a 1 here, a 1 over 3, a 1 over 5, a 1 over 7 respectively. So that's what I've done in this last step. I've common factored this. It can be removed only from the coefficients, and these would be the terms that result inside once that is common factored from the coefficients. Okay, I know that this is a very difficult topic, especially at first. Please spend some time with this video. The next video that I will post will be for Waveform 7. Okay? Okay, thanks a lot for watching.